Everybody, welcome back. It's Wojo. Today we're going to take a look at how to find the slope of some points if you're given a table. And oftentimes you might be given a table something like this that talks about, in this case it talks about how many hours you work and how much money you make. And they might ask some kind of question like, all right, how much does this person make per hour? How much does this person make per hour? Which seems like a fairly easy question to answer, but if you look a little bit closer, it's going to be hard to tell how much they make per hour just using the kind of strategies that we've done in the past. You know, if I look at, well, here he worked 5 hours and made $25. Oh, that's easy. He made $5 an hour, 25 divided by 5. The problem is, if I go down to 10 hours, it doesn't look like he made $5 an hour anymore. Here it looks like he only made $3.50 an hour, because if he had $5 an hour, 10 hours times 5 would give me $50. And it looks like no matter what hours he worked, it looks like how much money he made changed. And so this can be really confusing for students, and they'll often say, well, he didn't make the same amount per hour, but the story says that he did. Often the case in these linear type problems is there's some kind of what we call Y-Intercept, or money that he started with that's built into this. So maybe you get money for travel expenses, or maybe you get some money in tips, and this is including your tips and your hourly wage. And so it can be a little bit hard sometimes to find it. And so it's really helpful if we know how to find the slope of this, because the slope tells us the rise over the run, or in this case, if my Y is money, how much money I make per hour. And so finding slope extends way beyond just looking at points on a graph. It really happens in a lot of linear tables that we can have this. So what we're going to look at today is, all right, let's figure out how much money this person makes per hour, learn some strategies that we can use, and how that slope formula helps us out. So I just want to remind you that the slope formula that we have talked about so far says that our second y coordinate minus our first y coordinate divided by our second x coordinate minus our first x coordinate is the way that we're going to find slope. What we're going to look at today is, how do I do that if I give a table? How do I tell what my x1, y1, y2, y1, all those points are? And the nice thing today is, given a table, it doesn't matter which x and y values I pick. I can pick anything, and if it really is linear, if he really does make the same dollars per hour, it won't matter which points I pick. So I'm going to do a couple just to show you that. Give one more example, and that'll be kind of it. We'll have you guys try some on your own. These problems become really tricky, though, because of the way that they often ask. Not because the math is hard, but because it's just thinking different than we've thought before about these types of problems. So let's just look at one pair of information it gives us. It says that I work 5 hours and I made $25. So we can write that as a coordinate pair, saying this is my hours, this is my money. So 5 hours gives me 25 bucks. And then I can also look at a different one. It doesn't matter which other point. I'll just pick the next one. That 10 hours relates to $35. So we call these pairs, we call them coordinate pairs in algebra, but they're paired up. 5 hours corresponds with $25. 10 hours corresponds with $35. So it's just our fancy way of saying these go together. Now, if you remember, we could talk about these as points with x and y coordinates in algebra. And because this is the first point I'm talking about, we call it x1 and y1. Because this is the second point, we call it x2 and y2. And so now we can just take those numbers and plug them into our slope formula. So here our slope formula says take your second y value and minus your first. So my second y value is 35. And I'm going to subtract it from my first y value, which is 25. Of course, 35 minus 25, I know that's just 10. And that represents how much money I made in those hours. I made $10 when I went from $25 to $35. That means I went 10. So that's how much money I rose. If you think about slope as rise over run, I went up or rose $10. Well, let's figure out how many hours it took me to do that. So we divide it by x2 minus x1. So on this one, our second x value was 10 hours. Minus our first x value was 5. 10 minus 5, of course, is 5. So if we looked at this, we'd say, yeah, I made $10, and it took me 5 hours to do it. So I made $10 in these 5 hours. So $10 in 5 hours, well, 10 divided by 5 is 2. So that means he made $2 an hour. And I can verify this by just trying out different points and saying, well, does that hold throughout? Well, let me just pick 2 different points in this and see if it really changed the same, because it should if this is really linear and he made the same each time. So if I pick some different points, let's pick the 1035 again. So I'll start with the 1035 again. But this time, let's pick a different set of points to go with it. Let's pick the 3075 to go with it. So in 10 hours, he made $35. In 30 hours, he made $75. Let's do that y2 minus y1 again and find our slope. x1, y1, x2, y2. y2 minus y1 is going to be 75 minus our y1 is 35. So in this amount of time, from 35 to 75, he made $40. And let's figure out how many hours it took him to make that $40. So x2 minus x1 is 30 minus 10. So from 35 to 75, that's $40. From 10 hours to 30 hours, 30 minus 10 is 20 hours. Well, if I simplified this, $40 in 20 hours, or 40 divided by 20, it still comes out to the same $2 per hour. It wouldn't matter which of the points I did in here. I could do 85 minus 25 and 35 minus 5. I'm going to get $2 an hour every time because that's how much that person made. And so then sometimes students get a little confused and go, well, if he only made $2 an hour, why did he end up with 25 bucks? And so we can talk about this and say, well, his money, that's our Y, is equal to $2 an hour. But then there's some money he started with, and we call that our Y-intercept. So the $2 an hour, that's the slope. So whenever I ask something per hour or per anything, it's usually your slope. So his money is equal to $2 per hour. Plus, we could actually figure out how much he started with by kind of working backwards. In this case, we could probably figure it out. If he worked for 5 hours, and he made $25, $25 is equal to $2 an hour. Well, if he worked 5 hours, he would only make $10. So what would have to be in here for me to get from 10 to 25? So if I wrote this out, 25 is equal to $10 an hour plus what? Well, it looks like he made $15 some other way. Somehow he ended up with $15. Maybe that was some starting amount. Maybe that's travel money. But if I look at all of these problems, let's say I look at this 30, if he got paid $2 an hour, $2 an hour times 30 gives me 60 bucks, plus that 15 is what gets me to 75. Or $10 an hour times $2, or 10 hours times $2 an hour, that's 20, plus the 15 gets me to 35. So the reason why we can't just divide these out is because there's this extra money built in that you can't see. To help us figure out what that money is, how much money does he make per hour, it's really important to help us find slope from a table. So real quick, just to go over it one more time, how do I find slope from a table? I just pick any 2 points, and then I just do my slope formula, y2 minus y1 over x2 minus x1. Because one example might be a little confusing. Let me do one more example, and then we'll let you guys try some out, and then we'll talk about it more in class. All right, so let's come back and look at let's talk about a plane that's trying to land and someone taking the measurements of that plane over different time. So let's say the plane is just starting to land and it's at some height. Now we don't know what the initial height is because that would be times 0, but it was starting at some height, probably 10, 12, 15,000 feet in the air, and it was starting to land. And this is the chart. After 4 minutes of starting to land, it was 8,000 feet high. After 6 minutes, it was 7,000, and eventually it was going down. And so it looks like it took this plane a long time to land. At 14 minutes, it was at 3,000, so it was taking its time. But if we were looking at this and someone said, well, how fast was the plane descending? How fast was the plane going down? At what speed was it going down? How many feet per minute was it declining? We would have to look at the slope of this table to find out, because we know it didn't start at 0, 0. For it to be proportional, if it started at 0, 0, that would be fine, but this plane's not starting at 0 feet. It started at some feet above the ground. And so we're going to have to use our slope formula to figure out how fast that plane is descending. And so to use that slope formula, we're going to need to know a couple points. The beautiful thing about finding slope from a table is that you could pick any 2 points. So let's pick these middle points. Let's say we pick these 2. It would not matter what points we pick. And we're just going to say, well, how much did it change from each of these points? And we can just double check it by picking another set of points. But if I was doing these points, that's the point 6, 7,000, and the point 10, 5,000. Again, I can write them as coordinate pairs. It's just the shorthand version of how we write it in algebra to show that these go together. This is our x value, this is our y value, this is our x, y. That's what we call our coordinate pairs in algebra class. And then we just got to plug them into this formula. So we're going to take our second y value and subtract our first y value. So in this case, it's 7,000 feet. Sorry, that's not our second. Our second y value is 5,000. So 5,000 feet. Take away 7,000. So 5,000 being the y2 value. Should write that down. Minus 7,000, that's our y1 value. All divided by our x2 value, which is 10 minutes, minus our x1 value, which is 6. So in this one, I went from 7,000 feet to 5,000 feet. So if I asked you what happened, you would say, well, that plane went down 2,000 feet. And so some of you guys will realize you don't necessarily need to use this formula. Sometimes you can just look at it. 5,000 minus 7,000 is negative 2,000, which shows us the direction. Which way is this plane going? It's going down 2,000 feet. How long did it take for it to go down 2,000 feet? That's where this minutes come in. From 6 minutes to 10 minutes, 10 minus 6 is 4. So it went down 2,000 feet. It took it 4 minutes. So if someone wanted to know how much feet per 1 minute, if we actually divided this out, 2,000 divided by 4, ends up being 500 feet every 1 minute. And so this plane is going down or descending at a rate of 500 feet per minute. Negative because it's going down. If it was going up, it would be a positive number. And it wouldn't matter which ones I chose out of this table. I could have picked these 2 instead and did from 4,000 to 3,000. 3,000 minus 4,000, that's a negative 1,000 over 2. 1,000 divided by 2 is still going to give me that 500 feet per minute. So when you're looking at slopes for a table, that's kind of what you want to use to look at. So as you're working on these problems today, try to think about the hidden information in the table. Nowhere in this table does it say it's going down 500 feet a minute. Because these jump by different intervals, that's why it's helpful to do that subtraction. Let's look at the change in the y versus the change in the x. Let's use our slope formula and find that hidden information that's put in there. So good luck on the work today. If you guys have questions, as always, just ask when we see you next. You can always email. Hope you're having a great day and talk to you soon.